Okay, so in the previous video we talked about measuring pressure and temperature of CO2, and now we're going to discuss how to measure the volume of CO2. Now, in order to understand how to measure volume, we really need to understand the difference between densities of various types of states. So let's think a little bit about what volume means. Okay, if I have a flask that I would later on use to fill in my CO2 with, if I just take that flask out of the locker right now, currently the flask is what we call empty, but of course it's not really empty, it contains air in it. So the volume of the flask at that point is really the same as the volume of air that occupies the flask. When I run my experiment and I completely fill this flask with CO2, at that point the volume of the flask would be the same as the volume of CO2 inside the flask. And if I were to take out all the CO2 and fill the flask with water instead, then the volume of water would be the same as the volume of the flask. And that's really what I want to emphasize here, is that volume is just the space that something occupies. So if I want to know the volume of the flask, in this particular case, it would all be the same quantity as the volume of air, volume of CO2, and volume of water, as long as I fill up the flask completely with these substances. Now that we talk about volume, let's talk a little bit about mass. Okay, now what about the mass of this flask in each of the situation that we just talked about? In the empty case, really what I have, remember, is air. So if I measure the mass of this empty flask right now, what I'm measuring is the mass of all the glass components of the flask, right? So whatever glass makes up that flask, that has a certain mass. If I put a foil, aluminum foil over this to prevent the air from escaping, then the mass of the foil will also be part of that mass. But of course, the mass of air that's inside the flask will also be part of that mass. So if I call that mass M1, M1 is equal to the mass of the flask, which is the glass, plus air, plus foil. Let's say I take out all the air and now fill it in with CO2, and I measure the mass again. That mass will now be called M2, but as you can see, M2 is just going to be the mass of the glass plus the foil plus now CO2 instead of air. And if I replace the gases with water, then now the mass M3 is going to be equal to the mass of glass, foil, and water instead. Okay? Now, one interesting thing that I want to mention to you right now is, let me ask you, if I want to know what the mass of water is inside the flask, what is the method that we normally use to figure that mass out? Well, think about it. If I want to know how much water I have in this flask in terms of its mass, what I normally do is I take the difference between M3, which is this value right here, minus the mass of the empty flask, right, which is M1, okay? So notice that if I look at the constituents of M3 and M1, when I take the difference between M3 and M1, what I get is not mass of water, but it's really mass of water minus mass of air. But surprisingly, we never really care about the air. We would just say that this quantity is the same as the mass of the water. Now, why are we justified in saying that? Well, the reason, of course, is because water is much denser than air, right? So then the mass of air compared to the mass of water is insignificant. So this number is probably 1,000 times smaller than that number. So then we can say, for all practical purposes, that the mass of water minus the mass of air is really the same as the mass of water. And the reason for that is because the density of water is a lot higher than the density of air. Now let's consider our CO2. Let's say I want to figure out how much CO2 I have in here in terms of its mass, okay? So am I justified in using exactly the same method that I used to figure out the mass of water? In other words, can I take M2 minus M1, okay, mass of the CO2 filled flask minus mass of the empty flask, which we know is really not empty but it's filled with air. Can I just take the difference with these two numbers and say that that's equal to the mass of CO2? Well, let's think about this a little bit. We just said that M2 minus M1 is really not just equal to mass of CO2, but it's equal to the mass of CO2 minus the mass of air, right? Now, when we talk about water, we say that that quantity is the same as the mass of water. Now, the question we are asking right now is the difference between these two numbers is pretty much the same as just the mass of CO2? And the answer is, depends on the density of the two substances that we're comparing. Remember that we're justified in saying that mass of water is the same as mass of water minus mass of air because water is a lot denser than air. But if we look at the density of CO2 and density of air, you look this up online, you find that density of CO2 is 1.98, density of air is about 1.29. So CO2 is denser than air, but not by a whole lot. In fact, it's not even double. So if that's the case, my values that I'm subtracting right here would be fairly close in terms of number, so that it's really not correct to say that the mass of CO2 minus mass of air is going to be exactly equal to the mass of CO2, right? In fact, this quantity and that quantity would be very different because mass of CO2 and mass of air is roughly the same. All right, so if we can't just calculate the mass of the CO2 directly, subtracting it from the mass of the empty flask, which really contains air in it, how should we calculate the mass of the CO2? Well, if we really want to calculate the mass of CO2 in this case, what we have to do is subtract the M2 here from not M1, but the mass of the real empty flask. In other words, without air in it. Okay? So in other words, we have to take out the mass of air from M1 and then subtract M2 from whatever that remaining number is, right? If I go back to this picture, if I want to know what my CO2 is, first off, I have to take out the air from this flask. So I have a number that is smaller than M1, and that I can call the mass of the real empty flask, which only would be the mass of the glass and the foil. And then I would take M2 minus that number, and that should equal the mass of the CO2.